This video is part 2 of Chapter 1, The Science of Psychology for PSY 110S, the Psychological Sciences. In this section of the chapter, we're going to talk about basic research methodologies. I'm going to go over some broad categories of research questions and types of methodologies that fit with them, because I think it helps give you some context for the types of methodologies that are covered in your textbook chapter. So first, there are descriptive questions that researchers ask. And there are descriptive methodologies that go along with those questions. So basically, a descriptive research question is asking just what's there. For example, how many college students screened positive for depression and anxiety last year, so in 2023. That would be a descriptive question. You just want to know how many individuals in this case. Other types of research questions are correlational. Essentially, you want to know how variables are interrelated and whether or not you can use one variable to predict the level of another variable. So essentially what you do if you are asking a correlational question and using a correlational design is you're going to measure two or more variables and then determine using statistical techniques the degree to which those variables can be used to predict one another. So a classic example is high school GPA as a predictor of college GPA. And in fact, those two things are correlated. If you have a higher high school GPA, you also have a tendency to have a higher college GPA. Another example, you could ask the research question, are college students' depression screening scores associated with how stressed they are, or what's their level of perceived stress? In the research literature, we do tend to find a pretty strong positive correlation between the level of perceived stress and people's vulnerability to depression. Finally, there are experimental questions. And these are the questions where you want to know what kind of causal influence does one variable or several variables have on another variable or variables. So this allows researchers to draw conclusions that reflect cause and effect relationships. In order to test an experimental hypothesis, you have to use an experimental method. Now, for many of you, you've been acquainted with the experimental method in your K through 12 educational history, where you were taught how to write a hypothesis and then how to test an if-then kind of question. So if you manipulate one variable, does it cause a change in another variable? So for example, let's say that I have a peer support program that I've implemented at my university. Does a comparison between individuals who use the peer support program versus those who do not, is there a difference in their levels of depression scores or their levels of anxiety scores and so on? Now, there are a range of research methods that are covered in your chapter. They talk about observational methods that are used to test observational or descriptive hypotheses. There are correlational studies that are designed to test predictive questions or predictive hypotheses, and then finally experimental methods that involve manipulation of independent variables and the measurement of dependent variables in order to determine cause and effect. In laboratory type observational studies, you're using a space or a context where you can simply observe people behaving. And then documenting what their behaviors look like. So for example, if you have an observational laboratory like we do here at Mount Union, you could have individuals engage in a task and then document what types of behaviors you see. them performing, and that's a laboratory observation study. One of my favorite examples of a laboratory-based study that also has some naturalistic elements to it was a university many years ago basically built their own bar as a laboratory space, and then would have, students would come to the bar, and they just wanted to document things like how close people sat together, how far apart were they, what kind of topics were they bringing up, and so on. So they were unobtrusively observing the behavior in that setting. Now, a naturalistic observation study would be out in the world. So let's say you're interested in drinking behavior at bars. You would go to a bar as it exists in the real world and then observe people's behaviors. Another example would be going to a playground and observing children behaving and documenting the types of behaviors that you see. Participant observation is a little bit different. It involves people becoming sort of involved, embedded in a group, and then documenting the behaviors of the people within that group as a participant in that space. Case studies are studies that involve documenting the experiences of an individual over time. In psychology, most case studies are on the clinical side. So it would be a psychologist or a psychiatrist reporting on an interesting case and then sharing that information and insights coming from it to other clinicians in order to document specific experiences or events. Now, surveys are an interesting methodology. Sometimes they are for descriptive purposes, finding out people's attitudes, opinions, and values. The survey technique, though, as a tool, can also be used in correlational designs. It can also be used in experimental designs as well. So you have to kind of, in your head, separate out, are we talking about a survey design as a research method, or the use of a survey as a tool? Correlational studies, as I have already said, they're primarily designed to help you understand how variables are interrelated and whether or not you can predict one variable using another, and vice versa. And then experimental methods involve manipulating independent variables and measuring dependent variables. Now, in any type of research that you're doing, you have to be careful to really kind of check your biases and expectations at the door before you collect your data, and especially as you're in the process of interpreting it. So we tend to, as researchers, think we really have a good, solid understanding of what behavior is likely to look like. And we tend to be a bit overconfident, actually a lot overconfident, in our ability to make those kinds of predictions. This hindsight bias can influence the way researchers design their studies, the way they think about them, the way they interpret their findings. So it's something we always have to be careful about as we conduct our research. Now, as I mentioned before with the slide showing the table, there are three basic types of descriptive methods that your authors give attention to: observational techniques, case studies, and survey research. Observational techniques tend to fall into a couple of different categories. Observations where you are occurring behavior as it takes place in a natural setting, where the researcher is not intervening, and then participant observation studies where the observer becomes a part of the group that they are observing. Now, these kinds of techniques are not particularly common in psychology generally. They're a bit more common in anthropology and sociology. reasons for that are more just having to do with the culture of our different disciplines, but there have been naturalistic observation and participant observation studies done, especially in social psychology, which happens to be my discipline. Case studies, as I mentioned before, tend to be clinical in nature, and they may be a part of the neuroscience literature as well. Your authors give you the example of Phineas Gage, who it's a well-known case study where you have a man who lived in the 1800s who was injured working on a railroad, I believe, and he had a spike basically that went through his head and caused brain damage, but he survived and went on to live after that injury. So with the Phineas Gage story, what you have essentially is a clinical case study where his injury is documented and his recovery post-injury is documented and explained for other scientists, but also for the public. These case studies, they're fascinating, they're very interesting, but you can't, there's a profound limitation. You can't generalize from an individual case study to the general population. You can only do that kind of generalization if you do experimental research that involves carefully selected random samples, so that you have a much firmer footing for saying that this is a typical case. And that's a vulnerability for all case study research. A lot of clinical case study work, even though ultimately what you might want to be able to say is that you understand cause and effect. For instance, Phineas Gage had some pretty notable changes in personality after his injury. Now, you could suggest, based on his case, that the fact that the injury caused damage to his frontal lobe, perhaps those are related. Perhaps they're not. And the only way you would be able to know is to do more controlled study with a randomized population in order to understand what the nature of frontal lobe injuries actually causes. Survey research, as I mentioned earlier, is often descriptive in nature. So, we're in a political season. It seems like we're always in a political season. If you are a pollster, if you are a political scientist, you're going to ask a lot of questions to see where the electorate is at, who they plan on voting for, and so on. Essentially, what you're trying to do is describe the attitudes, values, beliefs, behaviors that are expressed by your sample. Now, survey research, when it's done well for descriptive purposes, you're going to have a population that you're interested in. For example, maybe you're interested in the thoughts of college students. Then you're going to pull a sample, ideally a random sample, from that population. So you're going to pull individuals from, say, a specific university or multiple universities, and try to sample them randomly so that they are representative of the population that you are most interested in. And then you have to be careful about the way you ask questions and the types of answers that your participants are giving you with those questions, because depending on the quality of your question wording, you're going to get different kinds of answers. Now, I mentioned earlier that surveys can, as a tool, aren't restricted just to observational questions. You can use a survey tool to do all kinds of research, a lot of correlational research, a lot of experimental research as well. So I don't want you to feel like, as I said earlier, you need to separate out surveys as a tool versus survey research methodology that's typically descriptive. Correlational methods, just to review here, what you're trying to do is to look at quantitative variables. And by quantitative, what I mean is they are described in numbers, so how much. And you're going to look at multiple variables and see how strongly they are related to one another and in what direction are they connected. Variables, I've used that word many times here already in this presentation. Variables are factors. They're concepts, constructs that you can measure with numbers, and they can take on more than one value. So for example, if I use a depression screening tool, a questionnaire, to assess depression levels in a population of interest, I'm going to assign each of my participants a score based on their responses to that instrument. And then I can use those scores either to be predicted by other variables or to predict other variables. So for example, I could use depression scores to predict the level of someone's self-esteem. I could also use scores on an instrument that measures perceived stress and predict the level of depression. So, either way, you're taking quantitative variables and using the degree to which they are related to help you understand their relationship. Strong correlations help us to understand predictions. So we can predict the value of one variable using the value of another. What correlations cannot do, however, is they cannot tell you anything really about cause and effect relationships, primarily because you haven't used experimental techniques, including experimental control, in order to test for those cause and effect relationships. All you can do with a correlation is talk about the degree to which and the direction in which variables are related. So, for example, as I said before, you could use two scales that generate scores that are quantitative, and you can test for the relationship between depression and perceived stress. What you can't say is the depression is causing the stress, nor can you say that the stress is causing the depression. All you can say is that they're related. Now, when you're doing correlational research, you're going to be using what's called a correlation coefficient, which is represented by the letter R. What the correlation coefficient does is give you a number that describes the type and strength of the relationship between variables. The math of it, basically, a correlation coefficient, an R value, is going to range from a -1 to a +1. 1 is a perfect one-to-one relationship, meaning if I know the value of variable A and I have a correlation of either positive or -1, I am absolutely certain of the exact value of variable B. 0 correlations, so if you're tracking along the line between -1 and +1, 0 is in the middle. 0 means there's absolutely no relationship, that the variables are unrelated to one another. The plus or minus sign refers to the type of relationship. Sometimes positive correlations are referred to as direct relationships. Personally, I find that language confusing. Basically, what a positive correlation refers to is as variable A increases in value, variable B also increases in value. A negative correlation, often called an inverse relationship, as variable A goes up, variable B goes down. So in my examples here, a positive correlation in the research literature, it's been shown that as perceived stress increases, so does the risk of depression. So depression scores tend to go up. An example of an inverse relationship, when people have more social support, so if you give them a scale where they report how much social support they perceive in their lives, as that goes up, depression risk tends to go down. And this graphic just shows the connection between these concepts that I've described here earlier. Essentially, you've got a -1 is the strongest inverse relationship that you can find. The closer you get to 0, from that negative. On that negative side, the weaker the relationship. Same for the positive side. The closer you get to +1, the stronger the relationship. Now, in most psychological research, and we do a lot of correlational research, you as a researcher, you're going to do a happy dance if you get either a positive or negative correlation that's 5-ish. That's considered, 0.5 is considered to be a fairly strong relationship. I can't say that there's ever been a correlation of 1 that I've read in the research literature. So that's like the ideal, but you're not going to find it. So we have to look at, the degree to which we have significant correlations between concepts. Now, these types of correlations, just to review what I've already talked about, positive correlations indicate a relationship between two variables in which, as scores increase on one variable, scores on the other variable also increase. So low scores tend to be paired on one variable tend to be paired with low scores on the other. High scores on one variable tend to be paired with high scores on the other. The reverse is true with negative correlations, whereas one variable increases, the other variable decreases. Now, visually, when we present correlated data, researchers will sometimes use what's called a scatter plot. It's a visual depiction of correlated data, and each data point represents an individual person's 2 scores graphed out on an X and Y axis, and I'll show you that in a second. The first 2 images that you're going to see are perfect correlations, so they're correlations of 1. The middle image is going to show no relationship, and the final image is going to show relatively strong positive and negative correlations. So here what you see, the pink line is a perfect positive correlation. The yellow line is a perfect negative correlation. The middle, the blue dots, they're randomly spread out across the graph, and that means that you can't use one variable to predict the other. The green dots represent a fairly strong positive correlation. The orange represents a fairly strong negative correlation. Now, one of the reasons why you can't make causal conclusions based on correlated data is something called the third variable problem. So basically, if you have 2 variables that are correlated, that could mean 3 different things. First, it could mean that the first variable causes the second variable to change. It could, though, it's equally likely that a change in variable B causes a change in variable A. In addition, it could be that an additional variable or variables are actually behind the relationship between variables A and B. So you have to be very careful when you're interpreting correlations, because you're going to have no ability to control for those additional variables when you're doing a correlational study. What you could have, in fact, you could find a fairly strong correlation between A and B, those variables. But if they are actually caused by another variable, if that relationship is being driven by additional variables, then it's likely to be what's referred to as a spurious correlation, meaning that the correlation actually between A and B, those variables, is meaningless. What's more interesting is the third variable that's driving it. So when you here, the example that you could use is about dogs and fire hydrants. A researcher observes that cities with more fire hydrants tend to also have more dogs. Now, these variables are related to one another. You could demonstrate that they have a high correlation, but the problem is that you have a third variable, and that variable is population size. So unless you take into consideration the size of the population, which is in fact driving both how many hydrants there are and how many dogs there are. The real interesting thing that tells you about both of those variables, which seem to be correlated but really aren't related to one another at all, the variable that explains both is how big the city is. So if you want to be able to talk about cause and effect, you have to do experimental research. Now, the tricky problem that we often get into in psychology, though, is that we run into difficulties being able to ethically and practically conduct systematic experimental research using human subjects. And that will be an ongoing theme as we move through the semester, talking about these issues. Experimental research is always the goal, but there are many, many research questions that we simply can't ethically or practically address using experimental methods. So, be on the lookout for that as we move forward. Basically, researchers who are conducting experimental research are going to have a variable that they believe has a causal impact on some other variable or a set of variables. And we refer to that presumed causal variable as an independent variable. And what you do as the researcher is you manipulate one or more of those independent variables and then measure their effect on your outcome variables of interest. So for example, one research study that I did with a group of students several years ago, I wanted to look at the impact of varying the type of television program that people watched. I wanted to look at the effect of it on attitudes towards people with mental illness. So I took an episode of the crime procedural crime scene investigation, CSI, from one season, where the murder took place in a forensic wing in a prison. So you had people who had done very bad things, but they were all described as having mental illness diagnoses. And it was very obvious in the episode that was there. So that was my high stigma television show. Then I picked an episode from the same season of CSI that had no mental illness content at all. And then I had a control video. It was an episode from the same year of a show called When Weather Changed History. So I wanted to see if when students watched the highly stigmatizing television episode, would they have more negative attitudes towards people with mental illness. So what I was doing there in that study, I was manipulating what type of TV program they watched, and then I was measuring their attitudes towards people with mental illness as my dependent variable. Now, essentially, in high-quality experimental research, what you want to do as the experimenter is control for all kinds of third variables. So you want to hold them constant. And that's the reason why the TV shows that I chose, the CSI episodes came from the same season. They had the same actors, the same performances, and so on. And I also chose a control video from the same year, just so that the quality of the videos would be roughly equivalent. And then I also removed all of the commercials. And then reinserted the exact same set of commercials in every video, so that I was controlling for any kind of weird impacts that commercials might have. I had the students watch the videos. This was before streaming. They had to come to a lab and watch it on a TV screen. They watched their episodes in the same room with the same sound quality, the same volume, etc. And they all then filled out questionnaires. So that's exerting experimental control for the purpose of holding all of those potential extraneous variables constant. And then you also want to do random selection and assignment to groups. So you pull your sample so that it's hopefully as generalizable as possible. And then you also want to randomly assign participants to groups. So in my study, students who signed up for the study, they were equally likely to be assigned to any of the 3 groups. So in experimental design, the hypotheses that you have as a researcher, like I hypothesized that watching the highly stigmatizing version of CSI would produce the most negative attitudes. And then I would compare my 3 groups to determine whether or not my hypothesis was supported by the pattern of the data. The variables have to be carefully operationally defined so that you have the ability to communicate with other researchers exactly how you did your measurements, so that they can repeat it if they want to. We also use language to describe the groups that we're looking at. In my example, I talked about a control condition. I actually had 2 experimental groups watching CSI episodes, and then a pure control group watching When Weather Changed History. Now, your authors give this example of aerobic exercise and anxiety, and they had, in this particular study, they had an experimental group that participated in an aerobic exercise program, and the dependent variable being measured was anxiety. They had a placebo condition where participants, they were participating in a different kind of activity, but not aerobic exercise. So, for example, they could be watching videos or something like that. And again, you still measure anxiety. So this would be equivalent to when I did my experimental group watching the nasty stigmatizing version of CSI, would be equivalent to the experimental group here on this graphic from your textbook. The placebo condition in the middle, that would basically be equivalent to my second experimental group condition where they were watching a non-stigmatizing episode of CSI from the same season, and then the pure control group, where you have, it's not a crime procedural and it's doesn't have stigma content either. And then you're comparing all of those groups on the dependent variable of interest, anxiety in this case. And you may have hypothesized that aerobic exercise is going to decrease the level of anxiety pre to post, more so than in the placebo condition and more so than the pure control condition. And that concludes part 2 of my coverage of Chapter 1, The Science of Psychology.